Today, we're diving into the story of a mind so massive, he's often called the last person who truly mastered all of mathematics and physics in his time. We're talking about a thinker whose work completely changed our understanding of, well, everything, from the way planets move to the very shape of space itself. Let's get into the incredible Henri Poincaré. The mathematician E.T. Bell gave him this title, the Last Universalist. And that sounds like a bit of an exaggeration, right? But it's really not. Poincaré wasn't just dabbling in different fields. He saw the deep, hidden connections between them all. He could bounce from the most abstract, pure math right into the nitty-gritty physics of how planets orbit each other. He didn't just play the game, he dominated it. So here's our roadmap for this explainer. First, we'll get a handle on just how wide-ranging his work was. We'll follow his path from a young prodigy to a legendary professor and see how he basically rewrote the rules of science. Then, we're going to do 2 deep dives on his most game-changing ideas, the birth of chaos theory and the invention of a whole new kind of geometry. And finally, we'll wrap up by looking at the massive legacy he left behind. Okay, so to really get Poincaré, you first have to appreciate the sheer breadth of his mind. I mean, it's one thing to be an expert in your field. It's something else entirely to be a master of the whole scientific landscape of your era. And just look at this list. It's really just a highlight reel. The guy wrote over 500 papers and 30 books. And we're not talking about minor tweaks here. His real genius was in finding these profound links between fields that everyone else saw as totally separate. He'd use an idea from number theory to solve a problem about planets, and his work on electricity was laying the groundwork for Einstein. He didn't see math and physics as all these separate little kingdoms. To him, it was one giant interconnected continent. So you have to ask, where does a mind like this even come from? Who was this guy that one of his own teachers called a monster of mathematics?
Well, he was born into a pretty prominent family in France. His cousin would actually go on to become president. And right from the start, Poincaré was a total prodigy, always at the top of his class. But here's what's so fascinating. He wasn't just some abstract thinker locked away in an ivory tower. Right after getting his doctorate, he also worked as a mining engineer and even personally investigated a mine collapse that killed 18 people. That blend of deep theory and gritty, real-world problems, that became his secret sauce for his entire career.
Now, before we get into our deep dives, you've got to understand this. Poincaré wasn't just solving the problems everyone else was working on. He was creating entirely new fields of study. He was changing the rules of the game itself.
So, for example, he figured out ways to understand the behavior of a system, even when you couldn't solve the equations for an exact answer. He invented a whole new type of geometry that we're going to get into in a minute. And yeah, years before Einstein's famous paper, Poincaré was already working out some of the key ideas of special relativity. He was basically building brand new toolkits for how to think about the universe. And that one idea, that understanding the general behavior of a system can be more important than finding one perfect number, led him to a truly revolutionary discovery when he took on one of the oldest, hardest problems in physics, the 3-body problem. The question sounds simple, right? You've got 3 objects in space, say the sun, the earth, and the moon, all pulling on each other with gravity. Can we predict where they'll be forever? I mean, Newton had already solved it for 2 bodies, and you get a nice, predictable orbit. But the moment you add that 3rd body, the whole thing becomes this incredibly stubborn, complex mess. And this is where Poincaré just flips the whole script. For centuries, everybody was hunting for a single, perfect formula. Poincaré came along and proved that for the most part, a formula like that just doesn't exist. So he brilliantly changed the question. Instead of asking, where will the planet be, he started asking, what is the nature of this system? Is it stable? Will the planets eventually fly off into space, or will they crash into each other? And exploring that question led him to the big one. He discovered that a tiny, almost unmeasurable change in the starting position of a planet could lead to a massively different orbit way down the line. This is what we now call sensitive dependence on initial conditions, and it is the absolute bedrock of chaos theory. It's why a weather forecast is a guessing game after a week. He showed that a system could follow perfect, simple laws, like Newton's laws of gravity, and still be completely, fundamentally unpredictable. So, as if that wasn't enough, Poincaré wasn't just thinking about how things move in space. He was digging into the fundamental nature of shape and space itself. And in the process, he basically invented a whole field we now call algebraic topology. You might have heard topology called rubber sheet geometry. The core idea is to forget about things like distance and angles. Instead, you look for properties of a shape that stay the same, no matter how much you stretch it, twist it, or bend it, as long as you don't tear it. So, to a topologist, a coffee mug is exactly the same as a donut. Why? Because they both have one hole. That's the essential property. And this gave us a radically new way to classify shapes, which, it turns out, is incredibly important in modern physics. This line of thinking led him to ask one of the most famous questions in all of math. He wondered, if you have any kind of 3D space that doesn't have any holes running through it, is it always fundamentally just a stretched or squished version of a sphere? This question, the Poincaré conjecture, was a beast. It took the world's best mathematicians nearly 100 years to answer it. It was finally proven in 2003 by the brilliant and reclusive Grigori Perelman. So, after all that, what is the lasting impact of a mind that touched literally every part of science? Well, to put it simply, his work is everywhere. These aren't just old ideas from a textbook. They are active, vital tools that scientists are using right now, today. Let me just give you a number, 51. That is how many Nobel Prize nominations Poincaré got between 1904 and his death in 1912. But here's the crazy part. He never won. And that's probably because his work was just too big, too foundational. It didn't fit into the neat little boxes of physics or chemistry. He wasn't just working in the science of his day, he was building the entire framework for the science of the future. I mean, if you study math or physics today, you simply cannot avoid his name. Just look at this list. Take the Poincaré group, for example. That's not just some historical curiosity. It is the mathematical foundation of space-time and Einstein's theory of special relativity. It's absolutely fundamental to modern particle physics. His name isn't a footnote in a history book. It's a headline in today's curriculum. And all this brings us to a really interesting final question. Since Poincaré's time, the amount of scientific knowledge has just exploded. I mean, it's grown exponentially. Today, scientists spend entire careers in one tiny, narrow subfield. So, could a true universalist like Poincaré even exist in our time? Or was he really the last of his kind, a product of a unique moment in history when it was still possible for one person to stand at the summit and see the whole landscape of science? It's definitely something to think about.